will you take one of these and pass it? Or take one of these and pass it. Y'all need one of each of these. We're gonna have a short quiz on the 10 organelles. Sorry. This is 9th grade science. You're getting a word bank, so they're going around. And okay, this is the animal cell, and there are 10 that I want you to fill out. And we went over these last week, so y'all should get them. And only do the 10 that are on your list. There are a couple extra things in there that we're not going to worry about. Like you want us to go.
I know two. Yeah.
Sorry, we're all to.
Y'all are ahead of me.
Can we talk to each other?
Okay, sure. In real life, it would be a graded quiz, but go ahead. Y'all can. Yeah.
Oh, okay. Oh, of course.
I think that was the ribosome.
Okay. I'll go ahead and let y'all keep these, and we'll just fill them out as we go. If that, okay.
Sounds good.
This will be.
Me too. That's what I would have got.
I have a question just about like this. If you were like teaching this, would you have collected these?
Yes.
Okay.
What? Okay. Okay, today we're going to discuss the functions of the organelles of the cell. And so this is what a really pretty colorful drawing of the animal cell looks like from a textbook. Okay, first we're going to talk about the cell membrane. And Maggie, can I get you to draw me a cell membrane on this lovely sheet of paper? Just kind of looking somewhat like the outside of that so we can fill it all in.
On here?
On here, big.
Big?
Mm-hmm. Just
Make it look like this one.
Okay.
Yeah, that works. Perfect. Can't really see your toes.
Here, I have some darker ones you can use there.
Perfect, thank you, Maggie. Okay. Alright, so the cell membrane separates the interior from the outerior of the cell, and it also allows for the exchange of different particles, things that the cell may need inside. We have different transport systems, simple diffusion, activated diffusion, which we will talk about next week. The next organelle of the cell we're going to talk about is the nucleus. Shonda, can I get you to draw me a pretty nucleus and then cut it out for me, and we're going to tape it in the center of our beautiful animal cell that Maggie drew. Okay, the nucleus is the center of the cell, and it contains the genetic material for every living being. So for plants, animals, bacteria, all of these things that have a nucleus.
Is it the brain of the cell?
Yes, it is the brain of the cell. Very good way to remember that. Okay. We also have cytoplasm inside of the cell. It's a jelly-like substance that holds all of the organelles in place. So, Kenya, will you color in pretty cytoplasm? Just whatever color, it doesn't matter. Yeah, that's good. Perfect. Yeah, the cytoplasm is all in the cell in between the different organelles, and it keeps things from, like, it's jelly enough to allow movement of vesicles, transport vesicles that need to get from one side of the cell to the other, but it's secure, rigid enough to keep things in place for if it gets smushed. Okay, we also have chromatin. Chromatin is inside of the nucleus, and it is actually what condenses to form chromosomes, which are our genetic material. And that happens during the interphase of mitosis, which we'll talk about in 2 weeks when we do our unit on mitosis and meiosis. So let's see. This is perfect. I'm going to take my function. Okay. Okay, can I get someone, Claire, will you draw some chromatin inside of the nucleus? It just looks like a bunch of little squirrely. Yeah, it
Is
looks
it
spaghetti.
inside of a circle or is it just squiggles?
Just squiggles inside of the nucleus.
Lots of them?
Yeah, sure.
Is that the nucleus?
Mm-hmm. However many you want to do, just lots of spaghetti noodles. That's perfect. Okay. Next we have mitochondria. And mitochondria is a lot of times referred to as the powerhouse of the cell. This is where a lot of the production of ATP happens, which is the energy that we use every day. That's how when we eat food, ingest it, then it's broken down and made into ATP. And so that happens in the mitochondria. So can I get, Tara, will you draw me a pretty mitochondria? And then cut it out. Will we do a couple of them for me? Yes. There are multiple mitochondria in the cell. And yes. Oh yeah. Perfect.
Just like a bean shape.
It is a bean shape, and it's got like a little matrix inside of it, so you can just draw a squiggle inside. That's a lot of times how it's depicted. Okay. And then we also have lysosomes inside of the cell. And these are used for digestion to break down different particles inside the cell and excrete them as waste. And so there are many enzymes inside of lysosomes that are, they phagocytose particles, which is engulfing them and bringing them into their structure, digesting them, and then they can release them, like go to the outside of the cell and release them to the outside of the cell. Yes.
On this chart, would lysosome be this one, or would it be this?
What's the other?
This one? Yeah, squiggles inside of it?
Because this one is going to be probably a vesicle that's transporting.
Which one is it going to be?
We'll go over that at the end. We'll fill it all out. Yes.
When we're looking up here, the drawing on the left is a full cell.
Right.
Okay, and then they're pulling. Okay.
Yes. And so the ribosome. Well, we'll get to ribosomes in a minute. But yes, the lysosomes are kind of big structures.
So the lysosomes on the right.
On the right, yes,
Okay.
it's pulled out, right. Okay. And yes, so they contain enzymes that break down particles in the cell and then excrete the waste to the environment to be. Okay, we also have ribosomes. Now ribosomes are the main structure involved in protein synthesis, which is very important, and we'll talk about that when we talk about the central dogma of biology. We talk about DNA replicates DNA, is transcribed into messenger RNA, and is then translated into proteins. And we'll get into that in the weeks that follow. But ribosomes have two structures, a bigger structure and a smaller structure, and it's what actually synthesizes the proteins that our body needs to function. Okay, you're cutting out some beautiful mitochondria. Can I get you to make just a little circle on the lysosomes that we just did, and then we'll probably do some little ribosomes. And ribosomes are just a little bit smaller than lysosomes, so yeah. Just some little circles.
Just circles?
Yeah, right. And yours, yeah, you can have some little particles in yours being digested if you want to. Okay. Next we're gonna go. Perfect. Do you want to tape them in there for me, just wherever? Okay. Next we have the endoplasmic reticulum. There is rough endoplasmic reticulum and smooth endoplasmic reticulum. The rough contains ribosomes on its structure, so that's why it's called rough, because it looks like it has a bunch of little bumps on it. And the rough endoplasmic reticulum is involved in protein synthesis because of the ribosomes, which we just talked about. And then the smooth endoplasmic reticulum is involved in lipid synthesis, which we'll get into later in the unit.
Where's the smooth on that? Like I can see the rough.
The smooth is up top, right here. It does not have any ribosomes on it, which is why it's considered smooth, no bumps.
Okay. Why does it have ribosomes on
The rough endoplasmic reticulum contains ribosomes because it's involved in protein synthesis, and so this is more in detail than we need to go into. But the ribosomes that are the proteins that are made on the rough ER are actually they become membrane spraining proteins that allow for the enter and exit of things into the cell on the cell membrane. So that's the difference. As just like free floating ribosomes, the proteins that they make stay in the cell. So it's just that's a little